Wonderful series of presentations we have heard. Thank you so much to all of the speakers. And now we can ceremonially roll up our sleeves. Please join me in doing that, unless you have tattoos that you don't want to show. And if you don't roll up your sleeves now, we're going to know that you have tattoos that you don't want to show. And let's rock and roll and come up with good thoughts, questions, insights, and strategies for this wonderful, wonderful, wonderful institute. So, sir, you can have the microphone. And we need a microphone for them too, for the fabulous four there, right?
So, I have actually two comments to make. Of course, very interesting, exciting, but I want to be practical. So the first comment, first illustration is in regards to things that we have in hand and are intriguing and give an illustration of the excitement and the potential. So the first example is beginning studies, only preliminary studies, but on halophil bacteria with their impressive DNA repair mechanisms, which is already partly published, but it is a very, very attractive source for this issue of DNA repair. The second example is what we have almost already in application, and Dr. Ophir gave on that same plant, desert plant, the Comynphora giladensis, or the balsam of Gilead, all right, the Moren levonine in Engedi. And we are actually in the process of converting its UV protection, striking UV protection, into a product. So these are two typical examples of potential for bacteria, of potential for desert plant, with already a clear, real implication. The second comment, which is more practical in a way in looking forward, what do we expect from you? What we, as researchers working here, what we would like to see? I think what we would like to see is, of course, if we had a billionaire come here and getting the vision of ourselves, then I can already tell you, like what has happened many times in the United States, $100 million or $300 million, and in 3 years you would have a fantastic institute like what we heard. So being realistic, and since we don't have yet that philanthrope, I think what is very clear is that each one of you should think on potential collaborations that we can take use of. It is possible. It is not a dream.
Dr. Benvich, wonderful comments, wonderful questions. Please. I have one on the philanthropist in a moment, but let's let them talk first.
One of the questions came up when I was looking at this institute and listening at these talks is the question for medicine. Which category of people could be candidates for profiting from the area here? Now, if you are looking at heart disease, acute cardiac events, they don't have the time to come here. Chronic heart diseases probably are not willing to spend the rest of their lives here. But there is probably something in between, which is the short to medium term disease that has enough time, who has enough time to come here and to stay here for a visit. And one of the examples of high altitude medicine in Switzerland are these tuberculosis clinics we had in the past before the effective tuberculosis drugs were there. There, 3 months of living your life up in the mountains could really change the disease course. Now, I had some exposure to hyperbaric oxygen therapies in the past, because as a young doctor I was kind of obliged to participate inside the tank with the patients we had there. This hyperbaric therapy is not very much en vogue anymore, in particular after one of these hyperbaric pressure chambers burned out with the patients inside in Europe. But if you think of hyperbaric therapy, there are a lot of scientific studies showing their specific effects in specific diseases. There you get a high dose of oxygen for a short time. So the question is, how can such hyperbaric results be translated to the Dead Sea environment, where you get a lower dose of oxygen, but you might profit for a longer time without the risk of being burned inside the chamber? For example, wound healing, could this be something where patients could benefit?
Any further questions? Yes, Dr. Siegel.
So I think that your point about getting leverage from outside is really an excellent one. And I guess it brings up the questions. I mean, I talked about ultrasound. My bet is there are a number of ultrasound manufacturers that would love the opportunity to be able to come, because there's such really high-level skin research that's happening here, and a number of universities who would love access to this. I guess one of the questions is how and why. In other words, how does this institute publicize itself? And how does it share its data? And would there be ways to be able to encourage that type of collaboration? I mean, I'm here, and I've learned a lot about what's happening here, but I can tell you the majority of my colleagues, at least in the U.S., don't know about that. And so I think, to your point, it would be great to figure out a way to be able to encourage those collaborations and increase the profile of the center, and then to let folks know what might be some of the opportunities for getting leverage and being able to do that sort of collaboration that you proposed.
Any further thoughts? If you wish, yes.
Okay. First of all, I would just a brief comment on your initial comment about the extreme DNA repair organisms. That has been very useful, and I think that's something that could actually be explored perhaps even more here, because the organisms living in this extreme environment, they must have some very, very interesting biochemical characteristics when it comes, for instance, to DNA repair. So that's something I think should just be explored 100%. I agree with you that I think it's important to promote this institute for the rest of the world. One way to do it is, of course, also to go on and publish the research in journals. That's something that is really, really a good way to promote a research institute. So I think that's important.
Thank you.
So, as you probably understand, I'm a microbiologist, an industrial microbiologist, so of course I can comment on the second part of your, on bacteria and on products we are looking for screening bacteria or plants. I think this part is really interesting, and I think that, for example, you can increase the visibility. I don't know if you already think about this, but to create like a strain collection or a plant extract collection which qualify you in the world, and anybody who wants to get some extremophile strains can ask you to give these strains and work together in collaboration. So this can be a practical suggestion.
Quick comeback, sure, of course, please.
So there are two responses that I need to make. Publishing, as you know, it takes time. So for instance, if I'll give you the example of the microbiome, in which I'm very much involved, it is only now that we have the first publication, and probably it would take another year until we have 3 other coming, and the DNA repair probably even more. So I think at this very critical point, what can come out of this conference is a bypass. In other words, a short leap. If Professor Rasmussen, if I pronounce your name correctly, if we think of developing this kind of work together, yes, that's a real response. The second question, the second answer regarding economy, the Israel insurance doesn't cover any treatment at the Dead Sea, okay?
Dr. Benvich, and also to address the questions that you had made about other things that we can do together and the philanthropy question. The GMP set up the infrastructure that we have for translation that is available to our partner institutions on the same terms as it is available to our own investigators. Through the protocol that we have signed with the distinguished president of Tel Aviv University, I believe that extends to all investigators here. So we'll be happy to work with you if you want to develop GMP manufactured things. We figure out a way to do this together. We have the facility. We'll be delighted to work with you on those. And not because I am running below capacity. I'm running at full capacity, but this is the way to change the world, so I'll be happy to work with you. And second, on the philanthropist question, the $100 million, $300 million, of course, that's where I spend a lot of my time. And I can tell you that most of the donors are Jewish. So I should be asking you, not you asking us. You know where those sources of funding come from, you know the successful people are. So there may be strategies that we can pursue together on that. Very good. So Dr. Horowitz had a question back here. Yes, ma'am, and then we go up.
I just want to make a comment
Yeah,
regarding...
I don't know that we can hear you. Can you turn up the volume there? Okay. Very good. Outstanding. Very good. Any comments on that? That's a wonderful observation that may lead to a real flow of patients. Thank you very much. Sir, and then I'll come down.
A comment and then a suggestion. The comment is I would be very careful about taking inferences from proteinuria and saying it's a good source of research, because if we look at the causes of death, in cancer, people have proteinuria. They are not at all the same as those of people who die of old age. Although they are interesting models of aging, they probably do not reflect the same type of aging that the vast majority of the population goes through. That's the comment. In terms of what you've done here, I've not really heard anyone touch upon this particular area. But as a physician, thinking about what is an area in which a great contribution would be made, really wants to become an orphan science, specifically antibiotics. As we all know, there is a rash of antibiotic resistance, and no one is working on it because it is not economically a nice thing to go into. The drug companies want to go into diseases that are not cured, for which you need to treat people for very long terms, hundreds of billions of dollars. They do not want to do the basic research that's needed to fight multi-drug resistant bacteria. If you can do that in any way, you would be doing mankind a great service, whether or not it is a great moneymaker.
So it's a great endorsement. Yes, please,
I
Dr.
completely
Marinelli.
agree.
Yes,
This is
completely
my
agree.
comment.
Absolutely, that's a great niche opportunity. It's a huge niche. It's not even a niche. It's a tremendous opportunity. So absolutely.
I have some specific questions,
Please.
starting with you.
Oh no.
Well, because you don't have a tattoo. These guys all have
Okay, I got
tattoos.
no tattoos. Okay.
No, I have a question about Watson.
Watson.
Yeah. So,
the IBM or the investigator?
I
Which
mean-
Watson? The detective or the computer?
The
from
computer.
IBM? Okay, or the DNA guy? Which one?
no, the computer.
Okay.
And so I noticed that you have a research activity at your center in
Yeah.
which you're looking at the information. And Watson seems to be setting a precedent for solving disease-related problems. Are you working in that direction? What is it that you're actually doing in that facility?
Thank you. And as a matter of fact, I'm taking chairman's prerogative, and on the third day of this event, I'm going to be giving a little presentation about my own research work, and I'll show you what we're doing in that field. Very central question. Thanks so much.
Okay.
So this means that Mira will give me 5 more minutes when I give my talk. You saw that. Thank you.
So I have specific questions for the people up there, if I
Please.
may ask them.
Please.
The first question had to do with the DNA repair that Dr. Rasmussen was talking about. You know, I worked at DOE with a guy who was studying aging, and he made a very interesting observation that if you plot the age of onset of fertility for all mammals and their overall longevity, then it was a straight line. And humans fall on that line at about 85 as our maximum age, on the line of age of onset of fertility for mammals. But there's a subpopulation of humans that live to be centenarians. They live well into 100. They used to be in Okinawa and in various parts of the world. Are you studying these people for their DNA repair, their mitochondrial repair? Are you studying the people that have proven that it's possible to live a lot longer, as opposed to studying the bulk of people who are going to die at 85 anyway?
Yes, we have done that. We have also studied twin centenarians, and unfortunately, there's no really major boost in DNA repair capacity or mitochondrial function in these people. And looking back, I think it's probably also because, as I said, I believe that there's a combination of factors. It's not one factor or 2 factors that needs to be deficient or improved, and then you can improve lifespan by 20 years. So to answer your questions, yes, we have looked into it, and there's unfortunately no major boost in these repair capacities in the centenarians, at least not the Danish ones.
The results that he was talking about actually showed that if you eradicate heart disease and eliminate cancer, you'll raise the overall population age by a couple of years. That it is really not a question when you're aging of dying of a specific disease, but your body basically falls apart for one thing or another.
You mean we are going to have to die?
I think that's true.
Oh no! I have to come all the way down here. All right.
So may I ask another question? Okay. I want to ask a question about oxygen. Oxygen is a real problem for species, right? You mentioned oxidants and the effect of oxygen. We've been talking about how good it is to have 6% more oxygen. But in fact, oxygen and oxygen singlets and all the problems associated with radiation are due to oxygen. Is it really good to have more oxygen, or could this be a problem? Also, the barometric work that the other doctor mentioned might be relative here.
Well, if you have a myocardial infarction, that is an ischemic disease, and you get oxygen in the nose in the ambulance, that will not be beneficial because it will lead to vasoconstriction in the rest of the body. So oxygen is not a cure by itself. But there are interesting questions. For example, there is this oxidative burst, which is used as a defense mechanism against bacteria. So there the oxidative properties of the oxygen molecule family is interesting. On the other side, there are specific diseases where hypoxia is a bad trigger. For example, the hypoxia inside a cancer is probably one of the important triggers that leads to change of the phenotype of cancer cells to more invasive species. So you might hypothesize that having a slight hyperoxia may be beneficial for patients at risk of progressive cancer. Who knows? I don't know. So I think you're completely right. Oxygen is not a cure for everything. Oxygen is one of the environmental factors, and it can be toxic or beneficial depending on the specific environment. Now, this is one of the questions which I believe could be an important topic for research. Up to now, we know of the impact of a kind of compound environment like heat and oxygen and pressure and whatever and salt here, but we don't really know what causes what. So the question comes up, coming here to experience the Dead Sea environment, is this the same as if you put the patient into a sauna in Tel Aviv once a day for a few months, or is it a completely different experience? So this might set up the setting for a comparative study of this kind. What is the real advantage of Dead Sea compared to something else, and could lead to interesting protocols.
Yeah, I like that answer. Hey, I have a question about ultrasound. Just a quick question.
Sure.
Then I'll stop.
Say something about
Okay.
I just want to comment about the oxygen concentration. So it's 6% out of the 21%, which means that instead of 21%, we have 22.2%. So it's not a 6% increase. It's not such a big difference.
Comment on that too. And what you have in the lung is got nothing. It's nothing to do with what's outside, because if the partial pressure it's going to modify your breathing patterns, and the partial pressure in the lung is probably exactly the same at 22% as at 21%.
Oh, but the overall impact of the barometric pressure here might be significant because we're at 400 meters. But I have a question for you about the ultrasound.
Yep.
Have you looked into robotic systems that would go inside the body and do ultrasound? I mean, I haven't read or seen anything about that, but I was impressed by what you were telling us about the skin and the penetration. But could you, in fact, do, you know, a swallowed version of an ultrasound thing that would then go survey your whole intestine, for example, as it passed through you?
Right, so the answer is yes. So there's both ultrasound that one can place into the esophagus, for example, or into the stomach to be able to, you can do esophageal echo and get a better look at the heart. You can do transgastric echo and get a better look at the pancreas. You can do intraoperative echo and go inside the body, and you can do intravascular echo. So there's something that allows you to be able to actually go into the coronary arteries with a system that is an ultrasound probe and do an advanced form of very localized ultrasound to characterize plaques. So in addition to going from the outside, there are all sorts of really cool ways to go inside the body and get even closer images. And when you're intravascular, then there's the capability of being able to go up to really super high resolution and be able to actually image the characteristics of a intracoronary artery plaque.
And it would be inexpensive, as you pointed out.
Yeah, so in comparison to some of the other modalities, it's relatively less expensive. The problem with going inside the body is it's more invasive, and there's a lot of really cool things that we can do externally, especially for skin. But for a lot of the things where we're looking for quantitative data, on a lot of the presentations that were done today and a lot of the research that's been done, I think imaging and ultrasound in particular will give us a lot of that, and it allows you to assess things real time. So you can image a patient today, this afternoon, tomorrow morning, tomorrow afternoon, as often as one wants, to be able to actually watch the progression of changes in skin lesions. You can do elastography of the walls of the heart directly without indirectly measuring some of that externally, actually, without going inside the body. So,
Well, you could even wear an ultrasound garment.
yeah,
right?
and that may happen in the future, and certainly to be able to monitor a number of different parameters. We're doing more and more Internet of Things, invasive and non-invasive monitoring.
I have one last question for the last speaker. Can I, or the last, just one last?
to smartphones?
Yeah, so the answer is yes. So as we're talking about ultrasound units down to $1,000, $2,000, $3,000, there are ultrasound probes, and the probes connect directly to a smartphone so that the processing and the computer analysis is being done by the smartphone, but you have an external transducer. And so those are becoming less and less expensive, and people are talking about those becoming much more a stethoscope. And we talked about artificial intelligence or machine learning applications, being able to take those data and then be able to have them analyzed by a machine learning algorithm is something that's happening more and more for all sorts of ultrasound and all sorts of medical imaging, including cardiac imaging. So absolutely.
Also for personalized medicine, that becomes huge, right?
Yeah.
Because now you have a long, long data set for
Right.
individuals.
Which brings up a really interesting point, and that is as we have these Fitbits and as we're acquiring information on glucose levels over time and as we're doing non-invasive monitoring of patient blood pressure, weight, pulse, et cetera, where does all that information go? And so to a large extent now we collect it, but we don't really make it actionable. It's not part of the electronic medical record. And being able to take those data and predict which patients are going to come into the emergency room, which patients are going to present with an exacerbation of COPD or congestive heart failure, and being able to use these technologies that are becoming less and less expensive, more and more ubiquitous, to actually help make decisions is going to be really critical. And in a really cool research center like this one, the potential to be able to monitor patients to actually see what is their basal temperature as time goes on, what's going on with blood pressure, heart rate, and can we monitor that over time non-invasively, and then make decisions quantitatively based on that. To your point, being able to look at the difference between placebo and non-placebo by actually monitoring it as it's happening in a quantitative fashion.
Sure, and in fact that would be applicable also for drugs. So when you're on a drug, you could be monitoring the effects of that drug at different doses.
Absolutely.
But I had one last question for the last speaker about the effects of antibiotics and vancomycin and these other new antibiotics you're looking at. How much work is being done on pre-treating the microbes before they're being exposed to antibiotics? And what I mean is the sort of the old Jewish chicken soup concept, right? That maybe there's things that you can do in addition to taking antibiotics to have a consortium of impacts on the microbes so that you heat stress the microbes or you cold stress them, do something in addition to give them antibiotics. And you know what I'm saying? So MRSA is fine against methicillin, it's okay. But what if you did something else before you presented antibiotics?
I don't know if I get your question, but I think that you can, one thing which is very important is the diagnosis of infection, of course, and to use the proper antibiotics and not to use large spectrum antibiotics for any kind of infection. But if you mean that you have to use something different or to prevent the use of antibiotics, I don't know if I get your question.
So my point is, can you do a suite of different things rather than having a magic bullet, i.e. an antibiotic?
You're saying can you do something to potentiate?
Exactly. Can
the
you
body
potentiate
response.
the antibiotic?
Put the patient in hyperthermia or hypothermia.
Exactly.
Could you go with a hyperbaric chamber, for example?
Right, or go to the Dead Sea.
Small molecule that might potentiate the impact of that.
Right. Even some of the, little,
Change the microbiome.
for example.
Now, in intensive care medicine, there is an intriguing observation, and that is the fact that some bacteria, like Staph aureus or certain gram-negative bacteria, are very resistant to current antibiotics, and some old drugs we have are not effective as antibiotics against them. For example, the erythromycin, clarithromycin family is not effective against gram-negative bacteria. But what we observe in intensive care medicine is that if you pre-treat severely sick patients with clarithromycin and then give an antibiotic which is effective against those bacteria, you have a lower mortality rate. And this is not well understood. Some people believe it's immunomodulation, some other people believe it's a reduction of bacterial toxin production which hurts you. But there are certainly mysteries in biology and treatment of bacteria in the clinics which hint to such combination approaches in the future.
Yeah.
They're just not understood yet well enough to be a kind of first line approach.
All right, so
This is probably related to the fact that antibiotics are considered chemical elicitors of bacterial population response. So we are used to consider antibiotic for antibiosis, but probably the role of this molecule in ecology, microbial ecology, is much wider, and they probably control the response of each population or of different population. They are kind of chemical message for changing bacterial response. So this is something which is completely not understood, and I think it's really interesting to study, but we are sometimes biased by the way to consider antibiotics as a drugs and not as what they can do in chemical interaction in the community. And I would like to come back to the comment that I'm not an expert of the medicine or health things we are discussing, but I think that it's very difficult to think about the modern medicine without the use of antibiotics. And so I agree that we are facing a period in which we probably bacteria are evolving, and companies are not working anymore in antibiotic field because it's not giving enough reward from this in comparison with other molecules. And academia is not used to work in this field. So we have a gap at the moment, and I think this gap can be very dangerous in the future because all the modern medicine we are thinking is done because you can give to the patient antibiotics before anything. So if antibiotics do not work anymore, we will have a big problem. And even in funding we have this problem, because I don't know in Israel, but in Europe there are funding only for products which are really very advanced, but I think we need funding for the beginning of the history. So for screening Dead Sea microbes or Dead Sea plants, or for screening to find new molecules. So
I was thinking of this morning's lecture when UV light treated water was killing all the fish. And it was the same story. We assumed that if you sterilize the water, the fish would be fine. In fact, the microbiome of the water was crucial to what's going on. And so if an antibiotic is targeting a group of microbes and changing your microbiome, it's how it's changing it. There may be probiotic ways of doing what you're talking about. And that's sort of what I was trying to get at. Can you pre-treat the sick person rather than having a silver bullet to go after what specifically ails them?
And that dovetailing on that, and now the recommendation is that we go pre-treat ourselves at the cocktail hour, as I received word from our great organizer. No?